Okay, Rich, so taking a closer look at your project, checked out your pictures on your boat, I came up with 2 or 3 different design drive shaft systems. This here is kind of an initial brainstorming sketch. As you can see, it's a jack shaft in the middle. This one would actually require a submerged prop, and it would go down at an angle right in front of the rudder. And this one's more of a V-shaft style. Did a little bit of research on the prop. I actually like the one you picked from eBay for what you wanted at surface prop. But another option, especially for these types of designs, would be a 3-blade bronze prop for fully submerged. I think you'll get better performance from that. So a closer look, I kind of narrowed it down to 2 different systems. First system would be a V-drive. You would actually place the engine in the back of the boat instead of up towards the front. I started taking a closer look in the gear and shaft system. So this is kind of a overall design that you could move forward with. The second design system is a U-joint drive system. This would probably require cutting up the drive shaft, so it depends on what would work for you, but it's another option. So I kind of took a look at what you already had existing in your drive shaft. First thing I did was a speed ratio calculation from gear to pulley calculation, and I used that to locate a pulley that would work with your clutch. I'll show the BMM, the bill of material later, but basically this type of calculation is used to choose the correct pulley and belt size for your existing shaft system and your engine. Here's some more system calculations. I wanted to actually kind of check to see if your shaft system was sufficient for the types of things that you wanted to do, and if it works well with the engine and the prop you chose. So again, I drew this U-joint system, noting that if you were to put one in, you'd have to have matching angles and uniform lengths. Also, if you were to, I picked some pillow block bearings in the bill of material, but if another route is to get a sealed bearing for the outside of the housing, outside of the boat, so it would actually, for the axle that goes outside of the boat, you could put a bearing in there that's sealed. All right, system 1. So these are bending moment calculations, or actually no, these are deflection calculations for the axle, just to make sure that it could handle, see what kind of deflection based on the weight of system 1 and weight of this system here. So that's what most of the following calculations are about. This here, again, this is kind of a calculation to figure out pulleys and speed and distances of pulleys based on the information we were given. And this is a bending moment calculation for the first system. The main thing that we're after here is this number and this amount, and comparing it with this amount. So the shear stress and the tensile stress of your axle. The shear stress is at 110,000 psi, and the tensile stress is at 140,000 psi. And through these calculations, we can see that your axle will withstand that because it's well below those maximum psi requirements. So all these equations, basically our conclusion is that the axle material, so the type of material it is and the size are sufficient for the designs I'm proposing. And here's a kind of a short list of all the different things that I've calculated to decide if they would work together. And to wrap it up, I just wanted to show you a printout of the bill of material. We have a 3/4 inch or a 3/4 inside diameter so that it fits with your drive shaft system, ball bearing pillow block, $68, almost $70. All this we have to take into account shipping. You would need a bushing for the pulleys that we picked, and also the clutch system and the belt. I marked this one option 2 because if you did want to go with the U-joint system, you'd have to purchase 2 single U-joints to put on your drive shaft system. Thanks, Rich, and I hope that best of luck to your project. I hope it all comes together and everything floats. Bye.